a root question. Okay, so let's look at question number 5. And this is out of 7-3. And we need to make sure that we know how to break up roots. This is something that you're going to have to do for college algebra. So the first thing we look at is we look at the numbers, and we've got that 343. So what I always like to do first is I like to see, first off, is 343 a perfect square? And it is not. So that's the first thing I always do, is I just check with the square root key to see if it's a perfect square. If it's a perfect square, you're done. This one is not. So we've got 343. Now, what we need to do is we need to break this down into pairs that can come out. So we've got a 343. Now, we need to break up this 343. We look at what it ends in, and it ends in a 3. 3 is an odd number. So we'll try things like 3. Let's see if 3 goes in there. 3 obviously does not go in there. 4 is an even number. It won't go in here. How about 7? 7 goes in there. So I can break 343 down into 7 and a 49. Now, what do we know about 49? Well, 49 is a perfect square of what? 7. We want perfect squares. We want pairs that we can circle and bring out. So what we have here is we've got these two 7s. Pairs come out as 1. So these two 7s are going to come out as a single 7. That's gone. What's left over? Well, what's left over that doesn't have a pair is another 7 inside, right? So whatever circle comes out in front has 1. And whatever's left over goes underneath that root. Now, what about the x squared? We're taking square roots. So that means two things come out as 1. This is an x squared, and you can even write this out, if it helps, as x times x. And 2 x's here are going to come out as a single x. So that means that the x would come out in front because we have an x squared and 2 of them are paired together, so that x comes out. And that's as far as we can go. So we broke up that root, and that x squared, well, it came out. Very similar to what you'll be doing on question 4. I did 5, you can do 4. Question 11. Question 11 is graphing of a circle. Let me find a better ink pen here. So we want to graph this circle. Now, what do we know about a circle? Well, for a circle, if I want to graph a circle, I need 2 things. I need a center, and I also need a radius. So let's now go ahead and try to find the center. And we'll talk about how we get the radius also. Here's a better pen. So let's talk about our center. Now, to get our center, we use what's called the center radius form. And the center radius form of a circle is x plus h, quantity squared, y plus k, quantity squared, equals r squared, and the center is going to be at minus h minus k. And your radius is simply r. Now, what do we know about this one here? This is our original circle. It's already in the center radius form. So what would our center be? Well, we switch out the numbers. So it started with a positive 4. So it would become a negative 4, right? We switch that out. Now, is there a y part here? No, it's just y squared. Is there a number for that k that goes with it? No. So that means my center is at negative 4, 0. So if you're missing a number with the x or the y, it's just a 0. And we always switch our signs. So this was a positive 4. We make it a negative 4. Now, what about my radius? Well, your radius is not 25. It's the square root of 25 because this is your r squared. And we know that the square root of 25 is a 5. And we may do another one of these just to make sure that we understand circles, because you'll see this in college algebra. It's one of the first things that we look at when we go to graph, as we look at circles. Now, how would I graph this circle? Well, I find my center, and that is at minus 4, 0. So that's way back here. And what do we know about our radius? Okay, our radius is going to be 5. So what do? We go 5 units in each direction. So we go 5 units in this direction. We go 5 units back to the left. We go 5 units up. And then we go 5 units down. And then we simply connect them together. And there's your circle. It's pretty easy to do. To graph a circle, what do you need? You need a center and you need a radius. Let's do another one of these because it's very important that you know how to graph these. So let's look at 12. These are easy to do, but I think they're important because you're going to see them again in college algebra. So let's look at 12. In 12, we've got x minus 2, quantity squared, y minus 4, quantity squared, equals 36. So what's going to happen to our center? Well, whenever we go from the center radius form to the center of the circle, what happens to my signs? The signs switch. So in this case, my center becomes a positive 2 and a positive 4. Switch your signs. And radius is not 36. It's the square root of 36, which is a 6. Is everyone okay with that? It's just a matter of getting the pieces and finding your center. Now, in college algebra, you're going to have to come up with this equation on your own. You're going to have to do what's called completing the square to get to this point. But at least you've seen circles before you get to college algebra. At least a brief introduction. Again, college algebra is just an expansion of what we cover in this course. So it's pretty much the same. We just add more. We talk about circles in college algebra, but we just add more. That's the only difference. So 2, 4 would be over 2 and up 1, 2, 3, 4. And what we now need to look at is our radius, and our radius is 6. So that means we go 6 units in each direction. So we go 6 units down. We go 6 units up. We go 6 units back. So 1, 2, 3, 4, 5, 6. And we go 6 units forward. And yours is probably going to be a better circle than mine. I don't have graph paper, right? So I had to put marks in myself. Yours should look like a circle. Mine looks like a football. But if you use that graph paper provided, yours will look like a circle. Okay, mine does not. because I was off. But you get the idea, right? It's pretty simple. Again, you're going to see this in college algebra. Any other questions out of 7.3? Anything else out of 7.3? No? Okay. Well, then we will start our next packet. And again, this is going to be our last one. So this will be your last homework packet before the final. Next week, we're going to spend the entire week working on the final, preparing for that final exam. Last homework packet. You're welcome. So we're now going to look at chapter 8. Oh, yeah, you do? So we're going to be looking at chapter 8. We don't have to cover all of chapter 7 or all of chapter 8 because not all of it is in our objectives. So I'm only covering what's in our course objectives. And the idea for this is to, again, just get you ready for college algebra. What we're going to look at today in 8.1 is a technique that you are going to be using from the very first day in college algebra. So this is something that you're going to be using that first week in college algebra and throughout the rest of the course. And this is what's called using the square root property. We're going to be solving using the square root property. So this is what we're going to be using today. So we're going to be solving using the square root property. Now, how this works is a step-by-step procedure, and it's very easy. First thing you do is you isolate the variable on the left. So left of the equal sign, we'll isolate that. Then what you do after you have that variable isolated is you take the square root of both sides. Now, step 3 is something that sometimes students forget, especially in college algebra and this class as well, is you don't want to forget the plus or minus. Whenever you take a square root, you're going to have to add in a plus or minus. And then step 4 is simply solve. So this is a very easy property. It's used a lot, and it's very important. So we need to make sure that we know how to use the square root property. So let's just solve a few of these with the square root property. And we'll start off with a very easy one. How about I have you solve x squared equals 16. When I solve this, I am going to get 2 solutions at most. Why am I going to have at most 2 solutions? Because this is what? This is squared. Now in mathematics, when we solve things, we always use opposites. The opposite of addition is subtraction. The opposite of multiplication is division. And the opposite of a square is a square root. So we're going to take the square root of both sides. Now, whenever we take a square root, you've got to remember to add on that plus or minus. That way you get the two solutions. And when I do that, the square and the square root, will those cancel? So on the left, that leaves you with an x. And then we've got the square root of 16, which is 4. What are my two solutions? I like to write them out. You've got x equals 4 for the positive case. And you've got x equals a negative 4. Okay. So that gives you the two solutions. Now, let's make it a little bit more challenging, a little bit different here. And let's see what happens if I give you this. First things first. And again, we're going to be solving here. And this is using the square root property. First things first is we make sure that that square has been isolated. Has this square been isolated? Yes. Now, not always are the numbers perfect squares. 90 is not a perfect square. How do we get rid of the square around that square, the square here? We get rid of that by using a what? Square root. And this goes back to what we just covered last week. We've got a plus or minus here. So that means we've got our two solutions. But what about 90? 90 is not a perfect square, but 90 breaks up into 9 and 10, right? And we want perfect squares because 9 is a perfect square of what? 3, right? Because it breaks down to 3 and 3. Let's remember what we covered last week with that negative as well. We know the double 3's here. They're paired together. That comes out as a 3. Then we have a 10. Now, 10 only factors into 2 and 5, okay, and no pairs can come out. Right? 2 and 5, there's nothing to pair up. So that's going to leave you with the square root of 10. And remember what happens here. Well, this was negative underneath the root, and if it's negative underneath the root, it comes out as an I. And what else do we still have? Plus or minus. So don't forget that plus or minus. Now, what are my actual answers? Well, our two answers are 3, I square root of 10, and also minus 3, I square root of 10. So one is positive, and one is negative. So you get the two solutions there. This also works when you have a quantity squared. And before we do a quantity squared though, let's look at one more where we have to divide and work it through. Just come up with something that's kind of similar to what you have in your homework here. Let's say 16, and let's say that equals 0. So again, let's try to solve this one. Once we solve this one, then we'll look at how we handle the quantity with the parentheses. So this one we're going to have to move around because as it is, we can't use a square root property because we need to make sure that this x squared is by itself. So think about solving for x. If you were going to solve that for x, well, you would just move that 16 over. And then once that's been moved over, what do you do from there? You divide by your negative 4. Right? And now we have x squared. Negative and negative makes it a positive 4. So how do we finish this out? Now that we've got the x squared on the left by itself? Well, we just take our square root, you add on your plus or minus. And what do we know about 4? 4 is a perfect square of 2. So what are my two solutions? Let's write them out. We've got x equals 2, and we've got x equals also a negative 2. Does everyone remember that so far? So it's a pretty easy process. You just simply take the square root and add on a plus or minus. You can also use this whenever you have a quantity squared. So quantity means we have those parentheses. So we'll start off with this one here. We'll start off with one that's a perfect square, and then we'll look at one that is not a perfect square. So again, we want to apply the square root property. Why are we going to use the square root property? Because we have a variable or a quantity squared. And now that has been isolated on the left, that whole entire part. How do we get rid of a square? Well, the opposite of a square, again, is going to be a square what? Root. Now, whenever we take a square root, what must we add in? Plus or minus. And this is something that you'll use from the very first class period of college algebra. That's why I think it's so important that we cover it. The square and the square root cancels out, and that gives you 2p plus 5 equals, we've still got our plus or minus. Now, what's the square root of 81? Well, the square root of 81 is going to come out to be a 9, isn't it? We're going to get two different answers. We're going to have to finish and solve two equations. So we've got to solve 2p plus 5 equals 9. And we've also got to solve 2p plus 5 equals a negative 9. So we've got to solve both of these. And now we just move things around. So we're going to move that 5 over here. And then we've got 2p equals, it looks like 4. We'll divide by our 2. And so one solution is p now equals a 2. So there's one of them. What about the other one? Same process. Move that 5 over. So 2p equals now a negative 14. We'll divide by our 2. And that leaves me with p equaling now a negative 7. There are your two solutions. Okay, so a square is the opposite of a square root and vice versa. And whenever you take a square root, do not forget to add the plus or minus. That's the most important part. It can get rid of a set of parentheses, like this one. What happens if it won't go away? If that square root won't go away. This was an 81, and 81 was a perfect square. But what happens if it's not a perfect square? Let's say, how about a 50 equals 0? So we're going to try to solve this. And again, we're going to be using the square root property. So isolate a square, use a square root to get rid of it. The first thing I would need to do is move that 50 over. Now, unfortunately, 50 is not a perfect square. So we need to break it down. And 50 breaks down into 2 and 25, and that's what we want because 25 is a perfect square of 5. We want perfect squares. And so these two 5s right here are going to come out as a 5. Because we're going to get rid of this by taking, I got ahead of myself here. Get rid of this by taking the square root. Don't forget your plus or minus now. So we still got our plus or minus here. So the 5 came out. What was left over? 2. Now, with this negative in front, or sorry, not in front, but underneath, what does that do? Well, that comes out as an I, right? So it's plus or minus 5i square root of 2. What's on the left-hand side? 2x plus 1. We still need to solve this for the variable x. Now, the square roots, those can't go with anything else, so they stay separate. And again, college algebra, you'll be doing a lot of these. We'll also see some more examples of this on Thursday when we look at the quadratic formula. So the first thing we'll do is we'll move that 1 over. And now we've got 2x equals minus 1. And you can leave that plus or minus 5i square root of 2. And now we can finish it. So just divide both sides by our 2. And so now we have x equals minus 1 plus or minus 5i square root of 2 over 2. And you can leave it like this in this case, or you can split it out. Doesn't matter. You can also split this out into minus 1 plus 5i square root of 2 over 2, or x equals minus 1 minus 5i square root of 2 over 2 there. You could either leave it as what I've got circled in green here, okay, or you can split it up. It's the same thing. A lot of times on a more complicated question like this one, I would probably just leave it as it is. This is what you'll see in college algebra. This also comes out sometimes of what's called the quadratic formula. So now, let's talk about another property that we can use. And this is called completing the square. So I'm going to show you how to complete the square here. I'm going to give you an expression, and you're going to have to make it factor and fill in the missing piece. So we want to make this a perfect square. So what we're going to be doing with these, and this is, just so we know, this is going to be like your homework, 8.1. This is going to be like 7 through 9. So we're going to be filling in the missing pieces here. So we're just going to be factoring and filling in the missing piece. So factor as a perfect square. And we're going to fill in the missing piece. So let's say I give you x squared. We'll work with an easy one. So let's say I have x squared plus 4x plus some blank. Now the goal is to get this to factor as a perfect square trinomial. So we're going to try to factor this as a perfect square trinomial. So how is that going to work? Well, we need to fill in that missing piece. And what we do is we half and square. Okay, so we're going to half and square. So what we first do is we half the middle. And then square. So we look at the middle here, and we look at this 4. Okay, so what's half of 4? Okay, we half it. So half this. Half of 4 is 2. And what's 2 squared? 2 squared is 4. So that's going in the box here. We use this a lot in college algebra when we talk about the circles. Let's do another one. Oh, let's say I give you, how about 10x? Now we're going to have to add in something to force it to factor. So what do? Half and square. So we take the middle, and that's 10. Well, what's half of 10? Half of 10 is 5. And what's 5 squared? 25. So that is what's added in to force it to factor. Let's do one more with a whole number, and then we'll look at ones that give us a fraction. And then we'll look at a fraction after that. So let's do another one. And let's say I give you, how about x squared? Let's use a minus. So how about x squared minus 9? X, and then you've got to add in something to force it to factor. Now, most of the time, they're going to come out as whole numbers. But 9 does not half out evenly. So what's half of 9? Well, it doesn't come out to be a whole number, so that's going to be x, and we're going to use a minus 9 over 2. Just put it over 2. And then how do we square it? We half this number, so half here, and then this gets squared. So what's minus 9 over 2? Quantity squared? Well, that's minus 9 over 2 times minus 9 over 2. And we know negative and negative makes it a positive 81. And 2 times 2 makes it a 4. So that would come out to be 81 over 4 there. Half and square. That's it. That's all you have to do. Let's do another one that gives us a fraction, and then we'll look at one that's a fraction itself. Half and square. So 15. Does 15 half out evenly? No. So what's that going to leave you with? And again, you watch the sign in the middle. What's a sign in the middle? Positive. We bring our x down. What about the 15? Well, 15 does not half out evenly, so we rewrite that as a fraction, and that's going to be 15 over 2. Then what do we have to do? Then that 15 over 2, we've got to square it. And how do we square a fraction? The easiest way is to simply write it out and multiply. So easy enough here. Half and square. If it's a fraction, just write it out and multiply. So we've got 15 times 15. So that gives us a 225. And 2 times 2 makes it a 4. That's going to be in the box here, a 225 over 4. So for questions 7 through 9, that's what you're going to be doing. Now let's look at one that has a fraction. And then we're going to learn how to solve equations by completing the square. So we'll do one more of these, and then we'll use this property to solve an equation. We've done a lot of pluses. Let's make it minus, just so you see a minus here. How about we use a minus 4/3 x? Now again, we're going to have to add in something to make it factor. What do? We half and square. Well, how do you half a fraction? How do we half a fraction? Multiply it by a half. So we've got our minus 4/3. We're going to have to multiply it by a half. That 2 and that 4 can cancel, and that leaves you then with a minus 2/3. So that comes down as x minus 2/3 quantity squared. Half and square. If it's a fraction, how do you half a fraction? Multiply it by a half. Easiest way to do it. How do we get the number in the box? We take this and we have to square it. So we have a minus 2/3. And when you square a fraction, you just write it out twice and multiply. So minus 2/3 times another minus 2/3. Negative and negative makes it a positive 4. 3 times 3 is a 9. So that comes out to be 4/9 there. Now we're going to have to apply this to some questions. And we're going to be using what we just learned, how to complete that square, to solve equations. So we're going to be learning now how to solve by completing the square. So when we want to solve by completing the square, this just builds off of what we just did a moment ago, as well as the square root property. So when you want to solve by completing the square, what you want to do is you want to make sure the variables are on the left. Then you complete the square. And you add to the right. So add on the right-hand side. And then once you've done that, then you take the square root. It sounds more complicated than it actually is. It's actually very easy to do. So this is called completing the square. I want you to solve this by completing the square. Now, we cannot factor it. Because can you find two numbers that add together, multiply together to give you 5, add together to give you 10? You cannot do that. Now, there are two ways that we can solve it. We can solve it by completing the square, which is what we're doing today, or next class period, we're going to learn how to use the quadratic formula. So let's try to solve this by completing the square. first thing we look at is we need to make sure that the x's are on the left-hand side by themselves. So that 5 doesn't belong there, so I'm going to add that 5 over. Now, we need to complete the square. Whatever we do to one side, we have to do to the other. So again, we half and we square. So that comes down as an x. Now, what's half of 10? 5. So that gets added here. Now, what do we have to add in to make this factor? Remember, we did this a moment ago. What went in the box here? Well, if I gave you this, half of 10 was 5, so that's x plus 5, and we know 5 squared is what? So whatever you do to one side, you have to do to the other. So we had to add 25 to make this factor on the left, so we have to add it to the right. Now we can finish it, because the 5 and the 25, those can go together, and that gives you your 30. And we just covered this earlier today. How do we get rid of a square? Well, we use a what? Square root. So let's do that, and we're almost done. Don't forget your plus or minus. In many cases, that square root is not going to break down, because 30 breaks down into 3 and 10. 2 and 5. But do we have any pairs that can be circled together? No. So that means that cannot be broken down. So what does the left-hand side look like? Well, it looks like x plus 5 equals, then we've got a plus or minus the square root of 30. So that's not going to break down at all. Now we can finish it. We want to get that x by itself, so you'll just simply move that 5 over. So x now equals a minus 5 plus or minus the square root of 30. And you could even write this out as two solutions if you wanted. You could write this out as minus 5 minus the square root of 30 and minus 5 plus the square root of 30. Same thing. You can either write it out, you could just leave it in this form. Either way will work. Let's do a few more. Sometimes you may end up again with an imaginary number, with an I. So again, we're going to be solving by completing the square. These are not going to factor, so we have to use a different technique. The technique we're going to be learning about today is completing the square. So what's the first thing we need to do? We need to make sure that the x's are by themselves on the left. So that means that 100 needs to be moved over. Is everyone okay with that? Now, half and square. So what's half of 18? Half of 18 is a 9. So that comes down as a 9. And then what happens when we square 9? Well, 9 squared is what? 9 squared is 81. So half and then square. What do we do to one side? you have to do to the other. We had to add 81 to force this to factor. So that means we also have to add it to the right-hand side. Okay, so that's why we're adding the 81, because if you add 81 here, this will factor. And whatever you do to one side, you have to do to the other. Now, this is not going to come out to be a perfect square. And it's going to be a negative 19. And I picked this one on purpose because what happens when we take the square root of a negative number? Well, it comes out as an I. And do not forget your plus or minus. So that plus or minus is right there. And this is going to come out now as x plus 9 equals plus or minus. The I is going to come out. 19 will not break down, so it's still going to be left as I squared of 19. Okay, and we can finish this by moving that 9 over. And now we have x equals a minus 9 plus or minus I square root of 19. So that is what we have. You could, again, break it up into the two solutions if you chose to do that. I think it's a little cleaner to leave it like this, but you can always break it down. Let's look at another one. Let's do one with fractions, and then we'll do one where we have to break it down at the beginning. Do another one here. Now this one's going to make a fraction. We'll have to work with that fraction. Same directions. Again, solve by completing the square. Let's use a minus 5x equals, we'll just use a 20 here. This one's already set up because we do not have to move anything over. That 20 has already been moved over. We've got the x's on the left-hand side. Just the numbers are on the right-hand side. Now, 5 does not half out evenly, does it? So that's going to make a fraction. We did these earlier, so we're going to have to work with the fractions. So that comes down as a minus 5 over 2. How do we square that minus 5 over 2? Well, to square minus 5 over 2, you simply write it out twice, multiply. And so that leaves you then with a 25 over 4. So the 20 comes down. And then we've got that 25 over 4 there. Now we do need to do a little bit more work with the fractions. Whenever you have a fraction, it's a little bit more complicated. And that's why normally you would use the quadratic formula, but we derive the quadratic formula by completing the square. But on a more complicated question like this one, we would normally just use the quadratic formula. But we need to get these together. So how do we get those together? We need one fraction. So we've got 20 over 1 plus 25 over 4. We're going to have to multiply this by 4 over 4, right? That way it'll work. 20 times 4, well, that's an 80. So we've got 80 over 4 plus 25 over 4. And when we add those together, we get a 105 over 4. So it is a little bit more complicated just because of the fractions. That's the only complicated part. So we have to get a common denominator, put them together. Now, how do we get rid of that square again? Well, whenever we want to get rid of a square, what do we use? We use the square root property. So we're going to take the square root of both sides. We're going to add on that plus or minus. And 105, it may factor down. We're going to see how to factor. We know 105, of course it has a 5 in it, right? You could do a 5 and 21. 21 is 7 and 3. So do we have any squares that are paired up there? No. So that 105 stays the same. But what about the denominator? Because it gets the square root as well. What's the square root of 4? The square root of 4 is what? 2. So it can come out. So the square root of 105 there. And we take that 4. The square root of 4 is 2. And how do we finish it? Well, we just move that 5 halves over with addition. And then we can rewrite this now as x equals 5 halves plus or minus the square root of 105 over 2. That's going to be your final finished answer. In some cases, you may have to divide out first. And that may induce fractions. Again, we're going to solve by completing the square. This one's going to require a little bit of extra steps, a couple of extra steps here. And this is one where normally you would apply the quadratic formula, which we'll learn about on Thursday, but I also want you to know how to complete the square. Complete the square is usually used for circles. Try to find equations. Well, first off, this is not in the correct order, and that negative 10x, well, that needs to be moved over. Because we need to make sure that we have all the x's together on the left-hand side. So let's move that 10x over. This one's a little bit different from all of the others that we've done. All of the others that we've done. Let's look at this one. Okay, we'll look at several of them. Look at the ones we've done before. We did this one before, right? Now that was a single x squared. Same thing with the last one. Okay? It was a single x squared. All of these that we factored here, they were always what? X squares, right? How do we handle this one? Well, this one has a 2 in front of the x squared. And we cannot have a number in front of the x squared. So we're going to have to divide it out. So whenever you have a number in front, you've got to divide it out. That may make fractions. And that's unavoidable. You're just going to have to work with the fractions. And then we've got 10 over 2. And that leaves you then with the 5x. And then we have a minus 3 over 2 on the right-hand side. What do we now need to do? Again, we half and square. So what's half of 5? 5 doesn't half out evenly, does it? So that would be x plus 5 halves. Now, what do we have to add in to force that to factor? Well, add in 5 halves squared. And what's that? 5 halves and 5 halves, that's a 25 fourths. So we just write it out and square it. We need to get these together into a common denominator. So that common denominator is going to be a 4. So this one has a 4. What does this one need? 2 over 2. So that is now going to leave us with minus 6 over 4 plus 25 over 4. Minus 6 and 25, that leaves you with a 19 over 4. And I've got that new homework packet for you, Wisdom, so let me find it real quick here. Just so you have it. Let me grab the right one. So I don't accidentally give you the wrong one. Okay. That's the one. Here we go. Here's the new homework packet. This will be our last homework packet. So this will be the last one. Next week, we're going to work on our final exam, getting ready for that final. So this will be our last, again, set of homework. So let's move this up so we can see. So we're at this point. Now, how do we solve this? We use a square root again. Plus or minus. 19 is not going to break down. 19 cannot factor. It won't do anything at all. So let's see what we've got left. So what do we have left? Well, we have left x plus 5 halves equals. Then we have a plus or minus. 19 will not break down. But what do we know about the 4? Well, 4 is a perfect square of what? 4 is a perfect square of 2. We can finish this by moving our 5 over 2 over. And now we've got x equals a minus 5 over 2 plus or minus the square root of 19 over 2. And that's your final answer right there. Let's do 2 more of these. So I'll do 1 more, and then I'll pick a question from your homework to look at as well. So we're going to, again, solve by completing the square. How about we look at something like this? Well, first thing we look at is there a number in front of that p squared? Yes. So we have to get rid of it. It has to be the variable by itself, so nothing in front of it. So what's in front of that p squared right now? 4. So we have to divide everything by a 4. That may make fractions, but that is unavoidable. There's nothing we can do about it. So now we are left with p squared, and then we've got 22 divided by 4. Well, that reduces down to be 11 over 2, p there. And then the right-hand side is a minus 15 over 4. Now we can finish it. So what's going to go here? Well, we have to half it. And how do you half 11 over 2? Well, you multiply it by a half. And that gives you 11. 11 times 1 is an 11. 2 times 2 makes it 4. So we're going to have to add in a 11 over 4 there. Half and square. And when we half a fraction, what do? Multiply it by a half. If it's a number, we just half it, but a fraction, we multiply it by a half. Now, we still have that minus 15 over 4 there, but we're going to have to work with that 11 over 4. So we have to square it. So how do we square 11 over 4? Well, we square fractions by simply multiplying them together. So we've got to square that 11 over 4. So 11 times 11, that should be 121 on the top. And 4 times 4 is 16. So we're going to have to add in a 121 over 16. Is everyone okay with that so far? These are a little bit complicated. Most of them are not this difficult. We need to put them together. Common denominator is going to be a 16. So this one needs a 4 over 4. Now we've got p plus 11 over 4, quantity squared. Now, what's going to happen when we multiply? We have 15 times that 4, and it's a negative. So that's a minus 60 over 4. And 121 over, 16 here, not 4. My mistake. It should be over 16. Right, because 4 times 4 here gives you that 16. And that's there. And what do we need to do now? These can go together. So 121 minus that 60. That gives you a 61 over 16. And we're almost done here. How do we get rid of a square? And this numerous times. Square root. Add your plus or minus. 61 is not going to break down at all. Nothing can go in it. So that leaves you then with a p plus 11 over 4 equals plus or minus the square root of 61. What do we know about 16? Well, 16 is a perfect square of what? 4. So now we can move that 11 over 4 over. And now we've got our final answer, which is p equals a minus 11 over 4 plus or minus the square root of 61 over 4. And that's as far as you can possibly go. I'm going to do one of these from your homework. There's several more for you to look at. But I'm going to work out question 13. And while we're working on question 13, I will pass out that sign-in sheet. So we're now going to look at question 13 from your homework. There's several more of these. And once we get started, I'll pass out the sign-in sheet. And this is homework 8.1. We're going to look at question 13. So we are going to be, again, solving it by completing the square. First thing we need to look at is, do we have a number, in this case, in front of the x squared? It could be any variable. In this case, though, it's an x squared. And yes, we do. So how do we get rid of it? Divide it. Divide everything by a 3. That may make fractions, and that's okay. You have no choice. So those cancel. So now we've got x squared plus 10 over 3x. And that equals minus 3/2. Now again, fractions are involved here. So we've got a square fraction and half a fraction. First thing we do is we half. How do you half 10 over 3? If you struggle with these fractions, you write them out. And you take that 10 over 3 and you multiply it by a half. This is the half part. So 2 and the 10 can cancel. That leaves you with the 5. So now we have a 5 over 3. So that goes down here. We still have that minus 2/3, and we now have to square. So 5/3 times 5/3, that is 25/9. Is everyone okay with that? Now we're almost done. We need to get a common denominator. So we're going to have to multiply this by 3 over 3. That's going to now leave us with a minus 6 over 9 plus 25 over 9. The left-hand side is still an x plus 5/3, quantity squared. 25 minus 6, well, that's a 19. So those can go together. And then how do we get rid of a square? Square root. Don't forget your plus or minus. Very, very important that you remember that. And what do we have left? Well, we are left now with x, sorry about that, plus 5/3 equals 19 will not break down, so it stays there. But what do we know about 9? 9 is a perfect square of what? Always check the denominator as well. 9 is a perfect square of 3. Move that 5/3 over, and we are done. So now we've got x equals minus 5/3 plus or minus the square root of 19 over 3. And that's it. And that's going to be your final answer, completely broken down for question 13. So what's our homework for next time? Well, your homework is going to be 8.1. And you should be able to do them all. There's completing the square. There's also using the square root property. So that's going to be your homework then for Thursday. And I will see everyone then on Thursday.